Hi, Chris Good here. We're doing problem 15 from chapter 11 in your statistics textbook. This is on page 332, and it's going to ask us to do a repeated measures t-test. So let's check out the question. Following data from a repeated measures study, examining the effect of a treatment by measuring a group of n equals 4 participants before and after they received the treatment. Step A is calculate the difference scores and the mean of the difference scores. So I'm just going to copy the table over here. So participant A, B, C, and D have scores before treatment of 7, 6, 9, and 5. After their treatment, it's 10, 13, 12, and 8. I'm going to look at the difference between before and after treatment. So 10 minus 7, and this is going to be a column of different scores. 10 minus 7 is 3, 13 minus 6 is 7, 12 minus 9 is 3, and 8 minus 5, also 3. We'll sum all of the different scores, so the sum of the different scores is 3 plus 3 is 6, and 7 is 13, plus 3 more is 16. The number of different scores equals 4, and so the mean difference score is equal to 4. That's 16 divided by 4. Alright, so we've calculated our difference scores and our mean difference score. B is to calculate the sum of squares for these different scores. And that's equal to the sum of the different scores squared minus the square of the sum of the different scores divided by the number of the different scores. So I'm just going to make another column of squared different scores to make this a little bit easier. 3 squared is 9, 7 squared is 49, 3 squared is 9 again, and 3 squared, 9 once more. So, sum of the different scores is 9 plus 49 plus 9 plus 9. And the sum of the different scores I already did at 16, so minus 16 squared divided by 4. Time to bring the calculator into play here. So 9 plus 49 plus 9 plus 9 is 76. Alright, that's 76. Minus 16 squared is 256 over 4. Should be 64. Alright, so 76 minus 64 is 12. Alright, so the sum of the squared deviations of each difference score from the mean difference score is 12. Final question. Is there a significant treatment effect? Well, to answer that, we need to do 4 parts, so I'm just going to number them here. 1, state the null hypothesis. The null here is that the population mean difference score is 0. Right? Step 2 is to determine alpha. It says use an alpha of 0.05 and 2 tails. Alright, so the t with, it's not 4, it's actually 3 degrees of freedom because it's the number of different scores minus 1. df for the different scores is equal to the number of different scores minus 1. That's 4 minus 1 is 3. So the t crit for 3 degrees of freedom, I have to use the t-table to look that up. Look it up on my Evernote is a fun program. It's a nice utility, and I do keep a t-table in my Evernote. So let's check that out. Let me find the right area here, and t-table. There it is. So I'm going to open that right up. The t-distribution. There it is. Okay, so two-tailed test, 0.05, 3 degrees of freedom is 3.182. That'll be plus or minus 3.182. Alright, back to our text. Step 3 is to calculate t. We already have the sum of squares, so I'm going to calculate the estimated standard error of the mean difference score. Sorry, I'm going to do the variance first. Which is the sum of squares for the different scores over the degrees of freedom. That's 12 over 3, or 4. Now that'll give me the estimated standard error of the mean difference score, which is the square root of the difference score variance over the number of different scores. Alright, that's 4 divided by 4. Oh boy, this is going to be easy. That's the square root of 1 or 1. Great. So t is simply equal to the mean difference score minus our null hypothesis population mean difference score divided by the estimated standard error, the mean difference score. That's our mean, which we decided was 4, minus 0 from the null hypothesis. We get this term from the null, divided by 1, or 4. 4 is beyond the critical value for t. Let's go ahead and draw our frequency distribution of t, right? Where the mean of all the t's is 0, and our critical values are here at negative 3.182 and positive 3.182. Shade those areas. 4's out here. That's where 4 is. 4 is in the shaded area. So last part, our decision is to reject the null. Definitely reject that null hypothesis. And we can even write a little sentence about this. So the treatment, let's write the treatment significantly increases scores. It's not sufficient to say that there was a significant difference. You need to say the direction. So significantly increases scores with a t at 3 degrees of freedom equal to 4, and p less than, because we rejected the null, it's less than our alpha of 0.05. And that's pretty much it for question 15.